Hello, Michael. Thank
Hi,
you.
Joe.
Thank you for interviewing with us at XYZ. Today's interview, we're going to be designing a five-state more finite state machine. Do you know what that is by any chance?
No, what's up?
So before I explain, here's a diagram that we're going to be using to explain, what we're going to be designing. Are you able to see the diagram?
No, where's the? Oh, I see the diagram now. Yeah.
All right, so basically, a five-state more finite state machine is a machine with five possible states. Basically the circles you see with letters in them. Each state is the letter, of course, A through Z. I think it's A through E rather. Um, each letter has its own output, either one or zero. Um, the arrows with numbers leading in between the circles. So for example, in the case of A to B, you see an arrow that has like a zero on it. Those arrows are the inputs into your machine. Your design will start at A. If you receive a zero, for example, in the case of our diagram, then you move to B. If you receive another zero, then you would stay in B. You know, basically that circle you see on B. Um, but if he receives a one at B, then you would move to D, and so on and so forth. Your design only moves from one letter to another when the clock is changing. So it cannot move when the clock, does not change. However, at any point in your design can receive a reset value, and it should reset back to A. Does that make sense? Do you understand?
Yeah, it makes sense.
Okay, cool. You can go ahead and begin whenever you're ready.
Okay. And the clock signal, is that supposed to be whenever a clock is going from 0 to 1 or from 1 to 0?
When it's going from 0 to 1, so on the positive edge of the clock.
Okay, positive edge. And then for the reset, do I start my machine with reset being 0 or with reset being 1?
So you would reset back to A when reset changes to 1. So when reset is 1
Oh, okay.
on the
Um,
we
okay.
call that active high.
So could you clarify what the inputs of the FSM should be?
Yes. So I can just go in here and add our module. Um, oops. Yeah. So I am, oh, there we go. All right. So our module, let's just call it FSM. This module is going to have our input clock, which is going to be logic, and then maybe our input reset, of course. Oops. Um, oh, and then we should probably also have our input at A, let's call it X, and our output from, from whatever state we're currently at, let's call that Y as well. Yep.
Okay. All right, that makes sense. Let's see. I think I'm gonna start. So I want my variables first. Then, because there's a clock, we want a sequential part of our design and the combinational element. And finally, the output, which will account for Y. We can actually, yeah, output would be Y. So we know we're gonna assign Y to something. Now, combinational. So since it's system Verilog, we're going to use always underscore calm for combinational. Then begin, and then end. And because there's 5 states, I think I can just use a case statement for that. So it's almost like an if statement, but this seems a little more cleaner for me. Now current. Oh, sorry. I didn't even declare my variables. Let's see. So since there's 5 states, I think I can do type the enum logic type and then 2 to 0. This will allow my binary value to go up to 5. And we can just name it A, B, C, D. and E, right? Yeah, E is the latest one. And let's just call our entire type state. Now, I want to make two types of this. So I think I'll have a current state and a next state. And for combinational logic, we know that our current state, if it's ever equals A, and we want to check if our input is okay, yeah. So if we want to check if it's 1, then our next state will become C, right? Yeah. Okay. Else, we can say that our next state will just be a solution. So it should be B. And then I think we're going to just actually copy and paste this. That doesn't look good. Yeah, okay. 5 times. Then so we have either it's B or C or D or E. So for B, we know that if it's 1, it should go to D. And if it's not 1, it should go to B. Yeah, it'll stay at B. But for C, it should go to C. But if it's 0, it'll go to E. Then for D, C, B, and then E should be D, B. Yeah, okay. So I think that actually should do for our combinational logic. So I'm pretty sure this just makes the entire design. So now we're already missing our output and some timing relation. So let's do always underscore F, pause edge, clock, begin, and end. Did you say the reset is supposed to go from 0 to 1 when we want to return to A?
Yes, that's right.
Okay, so reset it's high or it equals 1. We can make our current state A. But if it's low and we should make our current state equal the next state. Does that work? If reset high, current state A, else current state, next state. Okay. Yeah. Okay. So then that goes through the machine, but I think I still need to do parts for each individual output. So looking at the diagram, I see that we only have a 1 when your state is D or E. So we can actually just make a simple OR gate here. So we can do current state is D if that's true, or current state is E. Then that will give us current state. That will be true. So 1 or 1, it should always give us 1. But if it's either is false, yeah. Okay. Let me see. Current state and reset high. Yeah, I think this implements the diagram. How does it look? Oh no, sorry. I should have added a default in case that if none of the conditions are met, we should have a next day and just set it to A, for example. Yeah, now how does that look?
Looks good, looks good. Sorry, I forgot I was muted. I do have a question. Why did you use non-blocking statements in the sequential element and not in the combinational element?
So for combinational, you always want your equal signs to be blocking statements because it's combinational, so you always need an element to be used for the preceding calculations. But for your sequential elements, you always want your execution to happen at like the end of your procedure block. So in this case, this would only occur at the end of the block, but for here, it would occur in procedurally in an order.
Okay, sounds good. And looks good. All right, thanks, Michael, for hopping on this interview. And we'll get back in touch with you.
Okay, thank you. Thank you, Jeff. Have a great day.